Hello and welcome back to compiler programming. Today I want to work a bit on parsing. So the way that we handle kind of quote-unquote parsing right now is just with constant rewrites of the code. Like we find a match and then we replace it with a special value and then we find another match and so on and so forth. And this is sort of kind of been getting us through, but it has its problems. Namely, you have an issue with the order of operations. For example, like if we say that, let me get to rewrite plus or something. So here's our match expression. And this is more or less in the order in which we deal with the operations, but each one of them can technically produce some assembly or some machine code. And then the order in which these things are done is very arbitrary. And the only reason it's not really a problem right now is because we do not deal with registers still fully. So we try to only reserve registers for temporary operations, but then all of the values that are permanent, they are stored on a stack, and that means that this is why like we can sort of do operations in almost any order inside of expression, which is can be a bit surprising for the user and also not that great. So for example, this means that if we have two divides inside of the inside of an expression, they will be executed before the remainder, even though technically they should be executed one after another. So yeah, it's not great, and I want to fix it. I want to start with actually with the maybe constant expression, because it should be simpler than the rest of this stuff. Yeah, so here's our constant expression. So let's just try to figure out how we can deal with it differently. There are a bunch of ways how parsing can work as far as expressions go, because you need to take care of that operator precedence. And as I said, like for example, a multiplication should go before the addition, but it's sort of the same precedence as division. Yeah, so you can just yeah, there are a bunch of strategies how to deal with it. The one I like the most, honestly, is what is called Shunting yard algorithm. It's the basic idea is that you have, can I zoom this? Yeah, maybe that's probably better. So you have input like this, right? Maybe I will zoom even more. Yeah, much better. So you have input, and if you come across a non-operator, you just put it inside of the output directly, or like temporary output. Then when you have an operator, you put it in the operator stack. If it's empty, then you again put it in the output, the second thing. Then you get the next operator, and you check if the precedence of the operator is less than the precedence of the operator at the top of the stack right now. Since multiplication has higher precedence than the addition, we just add it to the stack. Then we push another item on the stack here, and then we have minus or subtraction. And subtraction has lower precedence than multiplication. So we pop multiplication off the operator stack. And in this description, they sort of like put it to the output and like reshuffle them. But in our case, we will what we will do instead is we will take B and C off the stack. We will do the multiplication, and then we will put the result of the multiplication on this output stack, and then sort of continue. And I guess, yeah, you pop the operators as long as the precedence of the operator that you're trying to put on the stack is less or equal to the precedence that is on the stack. So yeah, then you put D and then you put minus, and everything collapses into one thing. So this is the basic of it. There are a couple of extra things that you need to take care of, and I always find it a bit finicky to make it right, but it is something that definitely we can do. I have done it before in some form. The only tricky thing about this is the function calls, because in a sense they don't really have an operator. It is just that if you had something that was not an operator followed by parentheses, then it is a function call. It's it's a bit tricky, but it's just an extra rule to check when we are going through this loop. This is what we will be trying to implement today. And the reason I like this stuff is because it is very easy to extend it, right? I can just define new operator with new precedence, and the whole algorithm will continue working as it should be working. So there is nothing really extra to do here. It also is non-recursive. So that means that no matter how large the expression is, we will not run out of the stack space, and we will we cannot run out of memory, but there is a lot of memory, including swap. Like, your program needs to be really large for that to appear. So yeah, that's why I like this, and this is pretty simple and straightforward to implement. So yeah, let's get started. How will that look like? Well, let's say, so we'll still return the token, I guess, and then we say token parse constant expression. Okay, it will get the context, it will get the match, scope and builder. Yeah, let's keep all of this. We will need them. And now we need to figure this out. So, unlike previous things that just rewrite stuff, this actually returns things. So if we got an expression that does not have, that is basically empty, then I think we will just say that it is actually void. So we'll say value star. I think I actually have a void value, so I can just say return token make value make context allocator, and then I need to provide a source range. So let's do it like this. And so source range, or value and source range. First goes value, so void value. Okay, turn 0. Does that compile? Incompatible to compilation context. Okay, so we pass actually the call context there. That's easier. That's fine. Okay, so we took care of this being 0. Now let's continue with non-zero case. So what we do is we go through the state, and state start index I is less than of state tokens plus I, right? We get the token, Token star token is dynamic array get of state tokens I. And now we implement that shunting yard algorithm. So for that, we'll need two stacks. We'll need a stack of tokens and a stack of operators. So let's do that. Array token pointer token stack is dynamic array make of array token pointer, and well, later on we will even cache this, I guess, but right now it doesn't matter which allocator we use, as long as we free it up. So dynamic array destroy of token stack. Okay, so this is the first one. And the second one is the operator stack. And right now I'm just gonna do it sort of not a very nice way. I'll just push slices there. Operator stack, just so that we don't have to create a custom thing for operators. Array slice. Okay, so we have two stacks and we are ready to roll. So what do we do? Well, we say that if token type is token type new line, then continue. So that's the first thing. That's actually what is happening here. So we previously would just clear the new lines, but now we're just gonna skip them. Now if we say if token type is I'm not sure in which order it is better to do. I guess token type operator, then what? Well, then we need to do this comparison, and we need operator precedence. So for now, I'll just shove it in here. Operator, should it be an enum or should it be just a number? I guess it should just be a number. So let's say that this is going to be 32 operator operator or precedence for operator. And for now it will be hard-coded, but later on we can extend it. So we say slice operator, and here we can do things. So we can say we will assert that operator has length, right? And then we can do sort of extra parsing step in here. We will say, need to think about this. Later on, this will be a hash map. So we'll just look up the operator in hash map and then decide what it is. For now, I think I will just do the following. This is going to be very slow, but I don't really care at the moment. Slice literal. So we just straight up say if it is equal this, then we do this, else, and so on and so forth, right? And for this stuff, we actually only support negation, and negation is very tricky to deal with, because again it's a unary and binary operator at the same time. So you can have like 1 minus 2 and you can have just minus 2. Different languages deal with it differently. But the idea is basically if you are either at the start or if you had previously the previous thing is an operator, then the minus is unary, otherwise it's a binary. I'm not sure I will deal with it right now, but maybe we will. Now that I'm thinking about it, it looks like we don't really have operators here. So even that is not necessarily required right now. So instead, I will just say panic to do, and we will get back to here. But one thing that we need to take care of is token type parent. And this is the another tricky case because parentheses can be part of multiple things. They can either be sort of an expression or even the argument definition or a bunch of other things, but it can also be a function call. And we need to figure out how to distinguish between those two. If we look at the code, then it's visible that it is a function call if something before that is not an operator. And yeah, if it's not operator, it can be another function call, but it cannot be an operator. So that's what we will do. We will just try to do it in the stupidest way possible. We say bool is previous an operator and starts with, should it start with true? No, it starts with false. Actually, it starts with true because if we have braces at the very start of the expression, that is not a function call. Okay, so here we say if is previous an operator, then I do one thing, otherwise we do another thing. And if previous was an operator, then we just say dynamic array push of token stack and token. So getting back to this image, this will be this thing, right? So we look at something, in this case a is a parenthesized expression, we realize that it's not an operator in this case, and we will just put it in output, but replace output in your head with token stack. This is what we have there. Okay. Otherwise, this is a function call. Panic function call. Okay. So if it is not a new line, if it's not an operator, if it's a parenthesis, maybe I actually want to put a switch here and to make sure that I actually handle all the types of tokens I have. Okay, and token type, where is somewhere I can get this list of tokens? I'm pretty sure we have it somewhere. That looks good. Okay, let's put this here. And we're missing a star here, and we're missing usage of token operator. Okay, so getting back, if we have a new line, we just do continue. If we have an a module. This is, well, break. Actually, I go to error. So if we get a module, we not supposed to get a module here. I might even get rid of that token type, to be honest, but let's see. Okay, error report user facing error. Fix me. Square braces, for now, they are not implemented when we don't even have them. So to do, okay. Let me grab this stuff and we will put it inside of here. I do need to replace all of these things with breaks because we do not want to return ID string hex integer. Okay, break 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 and break. Okay, so we have this our skeleton for this stuff. Let's see. Oh, I actually did not put a switch here. Switch of token type. Okay, is that better? Yes, it is. We don't have unused operator stack, but we will use it in just a second. Okay, let's think about what happens to integers, hex integers, and strings. This is actually very easy. All of them are just pushed on the stack. Nothing really fancy there, so we can group them together. And identifiers might be a bit tricky, but we'll see how we deal with this. Token type string. Yes, for now, and actually value as well. So let's move identifier down. Yeah, that looks good. So any of these things, they just go straight to the operator stack. We don't need to do anything with them. So we take this and put this here. Curly one is also going to be interesting depending on how we decide to deal with the function definitions. I will think about it, but for now this is fine. Module, yeah, that's not something. We don't support square, and maybe I will put this here so it's more visible. And we have operator. Okay, so that sounds good to me. Now let's deal with the function call, or what is it here? We have token rewrite negative literal. Okay, let's deal with that. It's fine. Okay, if we also need to replace this is previous and operator with something else. So whenever we do a push to the token stack, we basically need to say false. And here, and in all other cases, we need to say true. That might be a bit annoying to track, but you know. Okay, if previous is an operator, yeah, then the previous one is not an operator. Okay, so if another thing about the minus is it is right associative. So that means that we need to look at the next thing when we get it. And that might be a bit tricky to do, but let's do something. So if slice equal token source slice literal minus, we need to check if is previous an operator, then this is unary minus, i.e. x plus minus 5 or something. Otherwise, it is a binary one, binary minus. Okay. Else, we don't support any other operators at the moment. So if it is a binary one, then this is very easy. We just need to do that operation. So we need to check. Then this is basically a standard collapse of this stuff. And that would be, maybe we just leave it, let it fall through. So we can say like this. If previous is an operator and it is a minus, so then this goes here. We say that this is a unary minus, and otherwise it's a binary one, and will be handled as everything else. And for this one, it's interesting. So we need to say what? We need to say that if I plus 1 is more than this is actually not correct, sort of. Yeah, this is not correct. So we need to look at the next one. So we say if there isn't a next one, then this report error and go to error. So if there is no next one, check that have a next token. Now we can get that next token. So we can say token star peak is dynamic array get state tokens plus I, and we deal with this stuff. So we what does this thing do? With this rewrite negative literal. Okay. We'll do it slightly differently. I'll just put this for now here, and then we'll figure out later what needs to happen. So we have this next token. We say that this is actually kind of interesting because I think we don't want to do it right away, and we actually need to do it in the same order as everything else. Because I'm thinking of this possibility where we have minus and then something like 42 and yeah, something like this. Because we don't want to minus the foo, we want to minus this whole expression. So it is actually about precedence and about right associativity. Actually, it should all go into the same bucket. The only difference is we need to distinguish between unary minus and binary one. So I just will do something sneaky. Okay, we don't need any of that. That will be handled later. And instead, let's do it like this. Slice operator is token source. And if we realize that it is a unary minus, then I will just pretend that the source is something completely different. I don't know. This is quite awkward, but for now that's fine. This should probably be, I don't know. We will say that this is something like this, maybe. I don't know. Unary. It doesn't really matter what we put here, as long as this cannot be a legal operator in the language. So that we can distinguish it when we deal with operator stack. Okay, this is good then. And then we get to here, which will get us a panic. And now the main thing about operators. We need to check if the new operator that we got in has lower or equal precedence to the operator that was there before on the stack. So I'll call it maybe maybe apply operators, and this will get an token stack, and it will get an operator stack, and it will get, yeah, we actually do need the precedence. So if it is an unary minus, I actually have no idea what it should be, but it doesn't matter. We'll just say whatever 10, and we'll continue with the regular stuff. Else, I don't know. Return 1. Everything else is 1. So unary minus has a bigger precedence. Everything else has precedence 1. Okay, and then we can do like this. 32 precedence is precedence for operator. Operator, I named this incorrectly, like this, and like this. And we need to pass all of this just there as well, which is a bit of a yikes, but what can you do? It's going to be a function that accepts a lot of stuff. Context, state, scope, function builder. Yeah, this is what it accepts. And it will also get these two. Token stack and operator stack. Okay. And U32 precedence. Okay, let's figure out what we need to do. We say if token, so if operator stack is empty, then we just push the operator. Actually, we shouldn't put it here, I guess. Um, let's call it handle token handle operator. And this is actually going to be void. And instead of putting, yeah, we should actually do this. We send an operator there. And here we don't actually need to do precedence just yet. And dynamic array length of operator stack. So if operator stack is empty, like in this case, we'll just push there whatever we have. It doesn't matter the precedence because there is nothing to compare it to. So we say dynamic array push of star operator stack and then slice operator. Yep, and return. Otherwise, we get the precedence of our operator and we start doing the comparison. So we do while. Actually, we can maybe fold this into the same thing. So while there is something in operator stack and precedence for operator, I guess this should be split into 2 lines so it is more readable. We have precedence for operator dynamic array get of I think I have dynamic array last operator stack. So we get the operator and is more, no, is less, less or more. What we have here. So if this one is more than what was there before, then we push it. So that means that while it's less or equal to precedence, we need to here apply the operator on the stack. Yeah. That actually means that we don't need this. We can just do like this because they are equivalent right now. Because if this will be false, we'll just not go through this thing and we'll directly do this. Okay. So while this is the case, we say that slice operator is dynamic array op of operator stack. And here is where we do the dispatch depending on the operator. So we'll have again something like this. This is super inefficient. I will replace it with hash lookups later on, but for now that's fine. So if operator, let's say it's a new operator. Yeah. And popped operator or something. If pop operator is unary minus then we need to token star Token is star dynamic array pop of token stack. So we get something of the token stack, and then we force that thing. So we say value is or value is token force value. I don't remember what force value takes. Force value. Okay, let's take this stuff and put it here. So context, then we have token. I guess it's like this. Value any and context allocator. So we get the token, we get the value, and now we need to negate it. And here comes that awkward thing with the fact that I think we don't have negation right now built in into compiler. So I'll just say if value type is value descriptor type is descriptor type integer, else panic to do. So if it is an integer and operand is immediate of value operand, then we have this, and I think we can again copy paste whatever we had in the negative literal, which is this stuff. So this is what we do here. It's not called result. It's called value, 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 value. Okay. That sounds good. Yep. Let's try to build and see how many errors I made so far. Yeah, you don't know what the operator is. That's because it's called a new operator. I missed a couple of results. And yeah, void functions are in the way. That's fine. We don't want to actually return here. So we say panic. Unknown what? Unknown operator. Okay, what do we have here? Cannot convert. That does not seem to be correct thing. Cannot convert const slice. Huh? Ah, yeah. And this should be operator. I don't know why I wrote minus there. Okay. So that actually builds. And now we're gonna break our code. We're gonna take this stuff. And we are gonna just put this in. Actually, I can name it the same way and then I don't even need to do anything. Right? Yep. Okay, so now we are ready to run it for the first time. It will be really bad, but it's fine. We can see what's going on. Okay, and we got a to-do. Okay, let's open up debugger and start working on this. I should have probably added more information to which exact to-do is happening, but it's fine. Okay, so we ended up with an operator. This should not be the case. We don't need to do this. And then inside of the function call, it is actually gonna be like this. And instead of an operator, we say that operator is gonna be open and closing braces. So this is gonna be our function call. Slice literal. Okay, let's try that again. We have a known operator. Okay, let's look at what is that operator. Yeah, that's actually a function call. That's great. Let's try to fix it up. So what do we do if it is a function call? If it is a function call, else if slice equal, well, let me just take this stuff. Easier than typing it in. So if it is a function call, and then we need to apply that function, right? And in our case, I think it's actually something different. Yeah, we have token write compile time function call. So what does this thing do? This thing, well, let's just take all of that. Call token range. Okay, that seems pretty straightforward. And here I actually forgot to do something. We sort of got the value of the stack, but we didn't put it back on the stack. So that's what we need to do. We need to say token star new token is token value make context source range would be token source range, and we set a value, we'll have value, and we'll say dynamic array push token stack and new token. Convert from source range to value star. Yeah, that should be the other way around. And yeah, that seems fine. I might want to extract this into the common thing, but well, let's not do that prematurely. What I was doing is I was doing this. I wanted to get our compile time function evaluation working. So we put this stuff, and actually when we come across parentheses, it doesn't matter if a previous was operator or not, we still need to push the parentheses themselves onto the stack, because that is I mean, that's kind of an argument to the function call. So in a sense, function call is sort of an empty operator, but we're just going to use this symbol. It doesn't matter which symbol we're actually using. So we do this, and if is previous an operator, if previous is not an operator, yeah, something like this. So we always push the token, and if previous is not an operator, we consider this a function call. Sounds good to me. Okay, let's try that again. Yeah, call tokens. Right. So for that, we will make a new array. Array token pointer. Definitely need to be more careful with memory, but for now I don't care about performance, so that's gonna be fine. Call tokens, and we say dynamic array push of call tokens, and we basically take two things out of the array that we have and put them in. But we actually need to put them in a reverse order. So how should I do that? I think I have a nice function for that. Dynamic array last. I only have first. Okay, so let's do it like this. We would say token star args is dynamic array pop of token stack. Then we pop the function. Then we push first the function, and then we push the arguments. Call tokens function, call tokens args. So this is the result, and then we put result back on a token stack. Missed a couple of stars. Okay, so that should take care of the token stack. The place where we will explode next, I think, will be with the function definitions, because that's something that we definitely don't support, and it might be a bit tricky to support that. But let's see. Okay, we still get an unknown operator. So what is that unknown operator? Popped operator. Yeah. So this is the arrow. We have no idea what to do with that. Good. We can try to figure this out. So in general, this should be sort of the same thing, more or less, as before. So let's start that. If we get an arrow, how will that work? So the problem is arrow is not exactly a binary operator. It wants to have more things of the stack, but that's actually fine. Yeah, I guess that's fine. So here's what we will do. We pop So the first thing is, remember that they are in reverse order, right? Because we were pushing them on the stack as we were going there. That means that the first thing there should be a body. Then we would have return types. And then we would have, what would we have? We would have arguments. This is what is with the function. And now we need to do something about it. Actually, there is also that inline thing now, which is a bit tricky. I guess what I need to do is say token star. Maybe inline is make array star star last of token stack. And we say that if maybe inline, so if there is last one, and if the last one is type is token type ID and source slice equal source inline. That's quite a complicated thing to check, but it's fine. So basically, we are checking if before our function definition, if there was an inline keyword kind of. And because we don't classify keywords as keywords when we are tokenizing, this needs to happen sort of here. Okay, so if it is inline, then to do handle inline. For now, that's not important. We remove this stuff here. Let's mark this thing. I will remove this mark, and we will get a function call, but a regular function call. Okay, so this is the thing that checks, not function call, function definition, function literal maybe. Yeah, maybe that's okay. Let me move this stuff around. So this is our function literal. And I think what I want to do here is I will split it into two parts. The first one is doing this matching, which will now be in a different place. But I don't know, I want to make sure that we don't break the previous cases if there are any. And here I will do, I guess like this. I'll take that out. And I will have value star token process function literal. And this is what's gonna happen. It will take all the regular stuff, and it will also take a bunch of arguments, which are these things. Yeah, something like that. So I will say bool, even though I hate bool arguments. We'll get rid of this function anyway, so it's fine. Is inline. Then we have token star args, token star return types, token star This will need some changes. So we have body. Okay. If body so this would be bool is external is body type is not token type curly. Yeah, that sounds fine. If is external, if is inline. Oh, we need the source range. Okay, for now I'll just comment it out and add a fix me. I don't want to dwell on this for now. So if external, if not body value return 0, it's fine. Allocating descriptor. We don't need to have this else. We have else. Builder, yep, that's fine. Okay, and then stuff here, and then I just do return result, and here I say value star result is whatever was this thing called, token process function literal, and we pass on all the stuff: context, state, scope, outer builder, our inline. Then we have args, return types, and token star body is honestly, I will just say like this. This will be easier. Okay, that seems reasonable. Let's see. Yeah, I have to replace a bunch of regular bodies and bodies with just the body. If is external, here, yeah, here if not is external. Yep. And body is inline. Okay. Body. Okay, it looks like this function actually works. But here we need to do a few more things. So this literal. Okay. And we don't have the result, but we will now. I'll say value star function value is token process function literal, and let's start dumping all this stuff in there. So all this, maybe I should put more of this in the context and like create context every function. I don't know, it's a bit annoying to pass all of these things around, but can't really do anything about that right now. Okay, like this, and the same as there. Bool is in the line is false. we first of all we say is inline is true, and we also say that we need to pop that from the list. Token stack. Okay, so that makes sense. Now we can pass is inline, and then we pass arguments, and we pass return types, and then we pass the body. Okay, and we need to create this thing, new token, result, function value, and the range. Yeah, these ranges will need to be better, but it's fine. For now, I will just use, I don't know, arguments as a range. Doesn't really matter what we put here right now. Okay, so we are building again, which is good. Let's see where we are crashing now. Or we might even actually try to look at what's happening here. So let's just step through the constant expression. It should also help you maybe understand what is going on. So we have some tokens, and these are the tokens that we have. We have parentheses, operator, parentheses. So this is a function definition. It is inside of here. This is like this function foo, and we are matching this stuff. So let's see how we will deal with this in our code. Let's get back here. We have token count. Let me switch back to local view. So we have 4 tokens. We have a range. We go here. We create this stack. And we start. We get the token. The first token is parentheses. Previous one is an operator, so we don't handle this. And we say that the previous one was not an operator. Great. What's next? Next is an operator. And I forgot to set something here, so that's good that we step through this. Here, once we handle an operator, we actually need to say that previous was an operator. I think, yeah. Maybe. It might be that handle should actually return to us saying what we need to do. We'll see about this. But for now, this should be fine. Let's get back to it. So it didn't break there. Did I remove the thing? Okay, not sure what's going on. Let's try 5. Okay. So again, going through, found the parentheses, pushed it. Move this here. Okay. Now next one, this is an operator. This would be an arrow, as you can see here. So these 2 bytes. Previous one is not an operator. We go into handle operator. Here we should get the precedence one. It is we don't have anything on the stack, so we just push this new operator on the stack. That's great. Okay, and now we have is operator true. We go here. We get another parenthesis. It was also an operator, so we don't consider this as a function call. We say that the previous was not an operator. We get to here. We not sure what that. That is very strange. What happened there? what was the last token that we had? It was the curly. Okay, let me try that again. I missed the thing, the place where things went sideways. So this is fine. This is also fine. And right now we can, for example, do this, add watch, and we can also do token stack and watch. Okay. So we have parentheses in operator stack, in token stack right now, and we have like parentheses in the. Wait, why do we? No, we have arrow in the operator stack. Okay, everything is fine. We get here, we get another parenthesis. This previously was not an operator, so we have two things in the token stack now. Yeah, we have parentheses for arguments, we have parentheses for return types. So this is fine. Okay, I know what the problem is. The problem is I don't do anything with the curly. Okay, so let's change that, and for now I will just shove curly into here. It is not, and maybe, honestly, maybe identifier should also go here. Let's keep it like this. Let's try again. Build and run. Go through this. First parenthesis, operator, second parenthesis, then we should get curly. Yeah, we pushed. Great. And now I need to add another thing. So we need to say token. It's not really handle operator. And in here, we basically need to forcefully process this stuff. So the way that would look like is, I guess, while dynamic array length of operator stack slice operator is star dynamic array pop of operator stack, and we do this. Yeah. Operator stack, we need to clean this up. Then we need to say if dynamic array length of token stack. So we should get just one thing on a token stack here. Say token star is one. You can say token star result is 0. We return result. If we have one, then it's very easy. Is dynamic array pop of token stack. Otherwise, fix me user error. So if we ended up with zero things on the stack, that means that something went wrong. Like we did not have enough things to work. if we end up with more than one thing on the stack, that means that we didn't have enough operators, and it's also a parse error. So we should end up with exactly one thing at the end here. Okay, that's that build. I forgot to do this, but otherwise seems fine. Potentially uninitialized. What? I'm initializing it here. How is it uninitialized? Will you be happy if I do this? Well, what is going on? I'm not really sure, to be honest. Why is it unhappy with me? Local variable, local pointer variable. If I do this, are you happy with me? No, you're not. I mean, I really don't understand what it wants from me. Are you confused with the name somehow? No. I have no idea what it wants. Can I do like pragma? I always forget how this works. SVC pragma warning pragma warning disable push. I guess this is what I want. I don't know what's wrong with it. I don't want to spend too much time fixing this stuff. Disable or what? What's going on? I have disabled this warning. Why are you angry at me? If I do this, will you be fine? Okay, whatever. I don't understand what's going on there, but let's just do it this way. Yeah, but this will actually not work. So maybe we'll end up with the same problem. Okay, like this, it's fine. Whatever. Let's continue with our testing here. So we go through all of that, we get an operator, we get another parenthesis, we'll get the curly, yep. And we are done. Now we have one thing on the operator stack, right, which is our arrow function. So we will go into this thing, we will get this function, and we will go inside of here. Okay, we'll get its precedence, which right now doesn't really matter. We have Um, yeah, that's actually not right. Um, so this will not work because we just popped it off the stack. Uh, yeah, that's not what we want. I need to split up this function into two. So I need to take this thing and token do handle operator. I know it's not very imaginative naming, but what can I do? And it gets all this stuff. And I will say token do handle operator context state scope. This will definitely not fit on one line, so let's spread it. Scope builder token stack operator stack and popped operator. And here we also do handle instead of this stuff. Okay, here we don't need to say popped operator, it's just operator now. Okay, and one more try. Honestly, now we can break in a different place. Instead of here, we can break in here. So we go in here, we go in here, we go inside. It's not a binary minus. This is not this. It is this one. So we extract it in reverse order. What is our maybe inline? It's not an inline. Indeed, it's not. So this will fail. But now we are ready to go into the function literal. We go in here. And it should not be external. We do this stuff and everything. So it's so body ended up being not a block. What was it then? Body. This is a invalid token completely. What is its source range? File. Source. I mean, the source is correct. Why is the type of the body 0? This is super strange. It seems that it came like this. Did I screw up something else somewhere and didn't notice before? It sort of just worked. Tokens. State tokens. Yeah, it's actually broken here. How curious. Let me run that again and verify that it's... Okay, so it wasn't broken, but it became broken. Who broke it? That is a very good question. So we go inside here. Body. Locals. Body. Yeah, here it's all still fine. So it is this function that somehow screwed it up. Okay, let's be careful and see what it does. Ah, okay. Yeah, I found what was going on. This is kind of awkward. What's it? Process. I mistyped. It's supposed to be like this. Yeah, well. This is where the fact that C has very poor type checking is coming through. That could have been a very long debugging, but hopefully I caught it in time. Let's try that again. For now, just skip and try to check what function value is. Well, it looks like we do have a function, which is very encouraging. I guess I will try to say F5 and 5, 5, 5. Well, we are progressing through the tests, which is great. We failed one of the tests. What is this one? Ah, it's compile time evaluation. Well, that's gonna be tricky. Okay. Oh, yeah. I know what is going on here. Yeah. So, a couple of things. First, looking at this, we need to make sure that function calls are actually more have higher precedence than arrows, which is something we can do and we will do right now. That's not a problem. But we also need to support this very specific function call because right now it tries to call a function called external. It cannot find it, and we have this error here. So let's do these two things together. I lost my do handle operator. So first we will add a bit of precedence to our function calls. In fact, I think they are actually first. So they have highest precedence. Then we have minus. That seems reasonable so far. But now I need to do something. And this is... Should I take a leap of faith and actually turn this external call into a function? Maybe not for now, but I will add to do turn external into a compile time function call. For now though, I will do the following. If function type is token type ID and function type function source slice equal. So basically we are checking just that if you have this very special function call which is external then we do one thing, otherwise we do another thing. And that's one thing that we are doing is external. Yeah, so this is an external import. And we can just call this thing. We'll have to create arc state, but that's fine. We can do that. So that is yeah, actually this is exactly how it is. Arc state, arc range. That actually looks good. Result token. So the question is, will you complain the same as you did last time when I did this? Or you will not? Let's see. Okay. Let's try to see if that works better than I did before. I will actually stop in here and check if we ended up in here. Somehow we didn't end up there, but at the same time, that's interesting. But we did pass the test that I think originally was failing. So what is this test? Actually, no. This is the same test. We are just now exploding in a different place. Okay. So I think what's going on is we did parse this thing, but at the same time, we failed to parse this one maybe. So we don't have any return types. What is the return types here? Return types is an identifier. Did I mess up I think I messed up the precedence, and this is what's going on. So operator has higher precedence. I mean, maybe let's put this back as it was before. So we do get to here. So whatever we do, we end up with the wrong thing. I want to do the following. I want to go to source. I want to go to here. And every time we are trying to process a function call, I want to know. And I also want to know when we get to this test. Aha, we actually fail before that test. Or it's bad at yeah, okay. Uh, let's see what's going on. Do we even get to here? This is awkward. How do I do this? I guess I will need to do a hack. Inline external function. Okay, so first of all, let's just disable this test for now and try to see where else do we have problems. That is much better strategy than trying to fix this one. At least for now. And I'll just run the test from command line. Okay, still have an assertion about a known descriptor type. Let's see where this one is coming from. So basically right next to it. This is also an inline function, so let's disable that one as well, and another one. I want to go out of inline functions for now. Okay. And we have the problem. And the problem is... Okay, fizzbuzz. Yeah, fizzbuzz also should be one of the last things we do, because this is one of the most complicated examples. Maybe I should just move it to be the last one, to be honest. Yeah, that might not be a bad idea, because it always fails. Or it always is the first one to fail if something goes wrong. Okay, well, we are even having a decent progress, but there is definitely something wrong with our code. So let's continue. I think it's actually that external parsing that is broken still. But let me take a look at which one fails. It's actually not. It's this one that explodes. I wonder. Well, let's do it here. I'll say avoid, I don't know, int x is 0, void x. I just use this so I can break there. Okay, I broke there, and now we can break somewhere here in our do handle do handle operator. Yep. Handle operator, rewrite constant expression. Okay, let's go. So what are we doing? First of all, what is our state? We have 4 tokens. This is pretty standard. If I look at the spec, We are in here, I guess. That is very curious. What happened to the previous statement? Okay, yeah, makes sense. Okay, now I get what's going on. So what is happening is we lazy define these two, and only when we ask for the test we start forcing this one. Okay, so that makes sense. Good. We get token count and get the stack, get parentheses, get operator, we put it there, everything is fine, get return types, it's fine, and we get a curly, which we'll put there. Everything is fine. We get to here, we get to here, we go inside, we do this, we do this, so we get the body. It is not an inline one, right? Right. So all of it seems very reasonable to me. So the question is, what goes wrong? I think I know what goes wrong. Yes. It considers this as a function call and it has no idea what to do about that. Which was previously these struct definition stuff. But let's verify that that is indeed the case. So we go inside. Here everything is fine. We go here. This is our block scope. And we do what? We go inside of there. Yeah, we do parse statement. And this is where it will inline machine code bytes. Okay, it was just wrong place, I guess. Anyhow, this is the second expression. Yeah, and here we have ID in parentheses. Okay, so the problem is the type. We can fix that, even though it's gonna be even more awkward than it was before. So else if, and here we have type. Ooh, that is very, very awkward because the way that the type is done right now, we expect there to be type, then this stuff, and then we would have curly braces in certain cases. And this is not easy to parse with this. Let me think about how to handle this case. I mean, one way I could do this is just to move the curly braces inside and sort of deal with it later. I guess that's what I will do. Okay, but for now, let's fix our current test problem. Okay, type ID type, okay, and we struct definition or something, rewrite type definition. Yeah, that is what is happening here. Oh, this is kind of awkward. Mm-hmm. How should I deal with you? I guess let's just copy all of this stuff and I will remove it later. Or maybe I will split it in two again. Or just change it. Yeah, let's just change it. Token rewrite type definitions, it's not actually used. So let's do it. Token process type definition. It should return us. What should return us? It should return us a token. We are not matching this anymore. We will get, well, we don't need the thing. We would say token star layout token. Okay. This goes away. And instead of replacement, we just say return token value make like this. And I will say layout block source range. Okay, fine. Pick index. Well, this is not happening. Error was undefined. Well, error return 0 or something. And we don't need this one. Okay, now you are correct. Here it is indeed potentially uninitialized. Result is token process type definition and all the standard stuff that goes into there. And let's just copy all of this. Have context state, scope builder, and we will pass their args. Okay, so that should make the current test actually pass. And we can break in there to see that we actually matched it correctly. Yeah. So access violation reading. Which one of you is 0? Layout block. Yeah, that was wrong. It shouldn't be layout block. It should be process type definition. It should be layout token. Okay. Let's continue. Well, we have actually successfully parsed this file and crashed on the next one. So what is the next one? And of course, the next one is structs. And this is where I will change how our stuff looks like. So what I will do is I will do this. C struct. Okay, you go inside. Good. And the reason it helps is because now we would have the children count. Okay. It will actually change slightly. How do I want to deal with it? This is so awkward. I need to match the arguments. Okay. External. Import match arguments. No. How do I function call? How do you look like? How do you deal with your arguments? Match call arguments. What are you doing there? Okay, so this is what it looks like. Okay. So we get the argument states. We split it by comma. That's fine. And function call. Function call. Let me think about this. It's getting a bit, the video is getting a bit long and my head starts to not work correctly, but I still want to push it through and get to a reasonable state before I wrap this up. I feel like the last few videos I was sort of ending them somewhere in the middle and it's not great. So let's figure this out. Okay, process type definition. Okay, we matched this, we split it into states, we have a mature state, everything is fine. And now we can switch on argument state. Case 0. Oh, actually, that would be default. Then case 1 and case 2. Okay, that is much better. If we have 1, then we expect it to be this. So we expect it to be a bit size. If we have 2, then we need to do some stuff. We need to say that layout type is this. So we have argument states. We say token mature state star First arg or layout type state is a dynamic array get of argument states 0. Then we can have 1, and this will be how do I call it? Layout block. Yeah. That's like this. We need to say if layout, no, that is still state. If layout type layout block block state is not 1, then we do what? Then we error out. Here, if it is not 1, we also error out. And we have another check that is basically this. So, but now we can say layout state tokens. So if we get two arguments, we first check the first argument. The first argument must be just one token. That one token is a literal struct, and we don't need to have this thing. We don't need to have this thing. And we don't even need to have this break. We just need to say, well, I guess we can do it like this. Token mature state, yeah. Okay. And layout block is this kind of stuff. It is going to be here. And otherwise, we error out. Okay, we can remove this stuff and see how many errors I made. A few, but not too bad. Here it needs to be tokens. And here it is like this. That's good. So we are matching against the sysstruct, and here it's the same. That's easy enough to fix. Layout children count. We don't need this variable anymore. Okay, so we are building again, which is great. The question is, did it help? Well, it looks like it did, because we were able to parse struct definitions. We were even able to call a function at compile time, which is pretty impressive, if I might say so. And now we panicked on an unknown operator. Okay, who are you and what is very unknown about you? So really, what is the operator? Locals, operator. Oh, operator at. So this is the compile time execution, and we are... I think I will not deal with this stuff right now because it's sort of the same thing as we just did with the other stuff. So I will just disable this test and see how it will go. Okay, we have another error, but we made really good progress. So all of this stuff, unsigned, signed, whatever. Which test are we failing on right now? This is... Hmm. So we are failing to look up main. Interesting. Why is that? Well, let's take a look. So the name is... So actually we are failing to look up exit process, and that's because it's an external. Yeah, I definitely have a problem with externals. External. Let me disable that one for now. And I think we might even succeed in the rest, or almost all the rest. Not really. So I think this bus is also... Actually, this bus is disabled. So which one is causing us problems? The same, because Hello World also has an external. So now we are just left with errors. The errors... Fine. No, they're not. Well, let's see what happens with errors and why we have a problem. Move value, force value, scope lookup force. Where is that? So we have the token type value, but the value is null. Okay. Result is 0 if token... Okay, I think that's the good way to fix it is actually not crash in this case. Where is our scope lookup force? Yeah, if token and token value. No, actually no. It is inside of here, force value. That if we do this, we can say if token value. To do, consider what should happen here. Okay, we are failing to build because I haven't stopped the program. Let's rebuild. And let's see what's next. Well, we successfully went through the first test, and I guess the second one... Yep, the second one has an external thing. The rest might actually work. I hope. Great. Okay. So realistically, it looks like the only thing that is holding us back right now is that external situation. And that's something I need to figure out what to do with. First of all, let's try to re-enable this stuff and see if that actually helps it. Okay. Let's see what's going on here. So we have rewrite constant, handle operator, do handle operator, and what do we have here? Maybe inline. Something is not exactly right. Okay, I want to look at this test in more detail. So where's our external functions? Dice 0 void I. Okay. So we stopped here. Now we can stop here as well. I wonder if I can make a breakpoint somehow such that it works everywhere. Stack, state, unlikely. Okay, whatever. Source range, token stack, it's fine. Actually, wait. Okay, so this one actually we need to skip. This one is perfectly fine. We need the next one. Here we should have, yeah, we have 6 tokens, or 5 tokens, no, 6. Parent stays external, parent, yeah. Parent. That looks about right. We put in parent-sized expression. Actually, did we put parent-sized expression? Wait. What is this identifier? It's inline. Okay, no, everything is fine. Now we put parent-sized expression. Good. We have operator. We don't handle it. We put it inside of there. Operator stack. Yeah. Now I know what's going on, at least with an inline one. And I'm not exactly sure how to fix that. Well, I know how to fix it hackily, but the question is what would be the right way to do this? And what is happening is if we look at this expression, right, we get an inline token and then we get a function. So we have parentheses, and these parentheses are like we consider this to be a function call, which is very, very awkward. And this happens because I actually said that arrow is, I mean, it happens in general. This is considered a function call. What do I do about that? I can just say that inline is a keyword. And if I add a keyword, then I don't set is previous. I say that the previous is an operator. This will fix it for now, but I guess I need to think more about what would be the right way to handle this stuff. Okay, let's do it this way. And I say if token type is not token type ID or token source or not slice equal token source. To figure out how to handle this better. Okay, let's get back here and try this again. I still have my breakpoint. Okay, somehow this is very much broken. Okay. Source. And let's try this again. We get the identifier. We should skip setting it previous as an operator. Okay. Now we get parentheses, previous, yeah, so we skip it. Great. Now we get an operator, which is arrow. That's great. We get parentheses, which is fine. We now get what? The token, it is an identifier which is external. Previous one is, say that the previous is not an operator. We go here, we get parentheses, we consider this to be a call. So let's try to step over, and ideally it should just import stuff. And it explodes. Okay. Try that again. Okay, now we got to external. And here's our stuff. So let's go inside and let's see what's going on. What is in our token stack? What is in our... So I guess I need to do this now. Yep. So you have ID, parentheses, parentheses, ID, and parentheses. That seems reasonable. What is the precedence? It's 20. And the last one, what do we have inside of operator stack? It's sort of the same stuff. I need to Okay, and in operators, we just have arrow. And now we are trying to handle the parentheses, which should have a higher precedence. So should it be the other way around here? Let me look again at the picture. So we put plus and we put multiply, and multiply has a higher precedence. Yeah, so it actually should be like this, I guess. Let's try it. Step again, and again. Some more. Okay, now we should skip over this loop. Yes. We push it on the stack. We say it's false. We will drop out of this loop. We will go inside. We will get this one. We'll get this out. And we should end up in external here. Yes. Yes. We get the result, which seems even correct, or correct-ish. We put that back on the stack. And now we have ID, parentheses, and value. That is great. Another loop, we go inside. We don't have this. Instead, we have an arrow. We get the body, we get this. We figure out that it's actually inline. So we should go inside of this if now. Yep, we did. We say inline it's true. We pop this out of the stack as well. We should have now, yeah, we have an empty stack, an empty operator stack. That is perfect. We get the function value. We get the result. We drop this out, and we are apparently not happy. Should report error on error for inline external functions. Yeah, so the issue is right now that we are not reporting error, but I'm okay with that problem. I will do a reporting later on. This is perfectly fine. So let's try to re-enable the next test and see if it works. Okay, this is expected to fail. This is fine. I will actually disable it for now. Now back again. Explicit return. Okay, exit. This one I will not implement right now. We'll try to enable this one. Let's see if that works. Okay. We don't have hello world because we disabled it. Let's put hello world back. Okay, now the real test. How about fizz buzz? And we even have fizz buzz. That's amazing. We can enable back this test, and I think we will only end up with one disabled test. No, we have compile time and we have the external things. Both of those things I will probably not test, I will not fix today. Uh, but that was quite a long video, which apparently also doesn't still work. Um, but I will clean this up later. For now, that is about all I wanted to do, at least on the video. I will continue cleaning up afterwards, so you will see a couple of commits coming after. If you're watching the repository, I will put the link in the description. But I think that's a pretty good setup. For now, this is only the constant expression, but you can imagine that regular, non-constant expressions will be a similar way, and we can have different operators available in different contexts. Also, you can sort of see that there is, even though right now we have a few hard-coded things, they can go away. Like, for example, this can be turned into a generic, like, oh, this is a keyword, and we have like is keyword here. Then here, the unary one, we can just tag some operators as unary, or like both binary and unary or something like this. So this could also be made generic, and the rest of the loop is definitely very generic here. Coming back to more complicated functions, this is pretty fine. We can have, like, this is essentially just a dispatch function where we match on the type of the operator and we do some stuff. So right now they are all inline, but you can easily imagine that there is a hash map that just maps the this operator to a function that will be doing some stuff. And in fact, this is sort of exactly what I'm gonna do for these things as well. So yeah, it's pretty good. The only tricky part is inline. I will think more about if there is a better way to do it, but if I have to define certain keywords in certain contexts, that's also not the end of the world. But yeah, this makes me happy. I will continue cleaning this up. I will probably transition all the rest of the stuff, all the rest of the code to this setup, and we'll be ready to go on further from there. But for today, that's it. If you made it this far, then you're really into this stuff, because it has been a very long video, and I thank you very much for watching, and hopefully see you next time.